Hello, welcome to Felix's Space Time. In today's video, we have an interview with Dr Ryan MacDonald, an Exoplanet Astronomer from Cornell University. If you enjoyed today's video, don't forget to like, subscribe and check out my Patreon page. There will be a link in the description. Enjoy. Thank you so much for coming on here for an interview. Can you tell everyone a bit about yourself?
Sure. So I am Dr. Ryan MacDonald. I'm an astronomer working at Cornell University in New York State. My research focus is on planets around other stars, exoplanets. I want to know what exoplanets are actually like, ranging from giant inferno gas giants all the way down to rocky planets in the habitable zone. And one day, I'm hoping that by studying these distant worlds, we'll be able to find signs of alien life out there in the universe and discover what such life might actually be like.
Wow. Can you tell me a bit about what you do on a day-to-day basis at Cornell University?
Absolutely. So at the Carl Sagan Institute at Cornell University, we're a collection of researchers that span many different fields of science. So we have astronomers like myself that use telescopes, both on the ground and in space, like the Hubble Space Telescope, to look at planets orbiting other stars. We also work closely with biologists, chemists, geologists. There are so many different things that you need to know to understand how planets actually work. And especially if we want to find signs of life one day, we need to have a good understanding of how life on our own planet works. So on a day-to-day basis, it's actually a lot of computer programming that I do. So I have written computer programs that will be used by NASA's James Webb Space Telescope, which will be launching hopefully in just about 10 days or so, and will be the first telescope that will be sensitive enough to look at rocky planets around other stars and potentially even search for signs of life in their atmospheres. So yeah, it's a lot of computer programming, analyzing observations of these planets, and trying to figure out what gases is in the air of these planets. So yeah, it's a lot of collaborating with people in many different areas of science, computer programming, pen and paper calculations. There's a lot of things that are required to be an astronomer.
All right, okay. You said a bit about using the Hubble telescope. Can you tell me a bit about how the James Webb Space Telescope could help you and your work?
Absolutely. So firstly, the Hubble Space Telescope has been fantastic for observations of exoplanets. We've used it to look at giant planets that orbit incredibly close to their host star. We call them hot Jupiters because they're around 1,000 degrees or hotter. But so imagine a planet like Jupiter, but orbiting 7 times closer than Mercury. So these planets are unlike anything we have in our own solar system. And because they are so hot, you can imagine them almost bulging out like a hot air balloon. And when one of these planets passes in front of its star, some of the light goes through its atmosphere. And we can use the fact that different colors of light are absorbed differently by different gases. Just like when you look up at the sky and you see that the sky is blue, that's because blue colors of light tend to bounce about and then spread throughout the entire sky. So different colors of light are treated differently by different gases. And we can use that knowledge to measure what gases are in the atmospheres of planets. So with Hubble, we've mainly been looking at giant planets to date because they're really big. They block out a large amount of the light from their star when they pass in front. But we haven't really been able to study rocky planets with Hubble. Hubble doesn't quite have a large enough mirror to get enough light for us to be able to do that. So one of the things that we're really excited about for James Webb is that because its mirror is much larger, it's 6.6 meters across, we will actually collect enough light that for the first time we'll be able to look into the air of rocky planets around other stars. And we really don't know what we'll find because we haven't been able to do this. So if you imagine in our own solar system, the differences between our own planet, the Earth, and Mars and Venus, they're hugely different worlds. One, obviously, Venus has sulfuric acid clouds. Mars perhaps was habitable in the distant past, but is a quite cold, frigid world now. You have to wonder what else could be out there if all the rocky planets in our own solar system are so different. Almost anything could happen for exoplanets. So we're just very excited because it's a true unknown question what rocky planets around other stars are like. And give it a year or so, and we will actually start to know for the first time. We're going to look at a lot of rocky planets with James Webb.
Wow, that's really going to help you then, isn't it? When did you first get interested in space and astronomy?
Oh, so I remember as a kid reading books about the solar system that had photographs in them that had been taken by some of the landers on Mars. And in particular, I think it was the Spirit and Opportunity rovers in 2004 took so many photographs on Mars while they were there. So when I was growing up, I remember seeing these photographs from the surface of another planet and remarking at how similar in some respects they look to what you might just see, I don't know, in a desert on the Earth. And that realization that machines that we had built had managed to land on the surfaces of other planets. And one day, hopefully in the future, people just like you and me could land on places like Mars and then look for signs of life. The thing that really kindled my interest in space was the question of whether we are alone or not. And the fact that I think we're quite close to getting an answer now. So Mars was really the thing that catapulted my interest in space and astronomy. My interest in exoplanets came just when I was finishing my GCSEs at school. NASA launched a telescope called Kepler in 2009 that was designed to look for Earth-like planets around other stars. And we hadn't found any at that point. And I remember seeing the news headlines and being so excited by the idea that we were finally going to know if there were planets like the Earth elsewhere in the universe. So that got me interested in exoplanets. And then when I went to university to study physics and then eventually went into astronomy, I knew that perhaps one of the best ways to search for signs of life. Obviously, we have planets in our own solar system, but there are so many planets in the habitable zone elsewhere in our galaxy that it seemed to me that the best place to look for signs of life would be to get involved in exoplanet research. So yeah, it's just, are we alone in the universe? That's what got me interested in space. And I'm just so excited that now I get to actually help to try and answer this question.
Yeah. What do you can you tell me a bit about what you do on your YouTube channel?
Sure. So my YouTube channel, I started it when I was in university about 7 years ago. It's called Martian Colonist. So it kind of goes back to my interest in Mars. So I've always had a fascination with people going to Mars and wondered, when will the first people land on Mars? What scientific discoveries will we make there? And one day, could people live on Mars? So my YouTube channel I make videos talking about how far off we are from sending people to Mars. So I don't make as many videos now as I once did. At the moment, I make a couple videos a year that are long, almost documentary style review videos, talking about all the different things that are happening that are making us closer to sending people to Mars. So the last one I made was in June of this year. And it's like a 40-minute video or so talking about all the different things, like what SpaceX are doing with their Starship system, for example, the landing of the Perseverance rover and China's Zhurong mission, just kind of summarizing all of the things that are happening in the big picture about Mars and sending people to Mars one day.
Okay. Wow. Would you ever go to another planet to visit or to stay?
I would love to go to Mars one day. Perhaps my long-term dream, I would love to set up a university on Mars. I think we're getting closer. We're getting a lot closer. And when I was growing up, everyone was always talking about 20 years from now, maybe 4 or 6 people would land on Mars. It would be very much like the Apollo missions. But now things have changed in a really encouraging way. Now people, especially with the invention of reusable rocketry like the Falcon Heavy flying at the moment and soon the Starship vehicle, we can now actually imagine being able to land 100 tons and 100 people on Mars in an affordable way. And it's that kind of change in technology that will, I hope, enable people like myself to one day go to Mars. So yeah, I would absolutely be interested in doing this. I plan whenever there is an astronaut selection process open to apply for it. So yeah, that's part of the dream. So either I'll be using a telescope on Earth to look for life on planets around other stars, or I'll be on Mars myself with a shovel looking for signs of ancient life there, perhaps underneath the surface. So yeah, I would really love to go to Mars one day.
All right, okay. Would you go to any other planets other than Mars?
Well, in our own solar system, there aren't many other particularly nice places. There are loads of fascinating moons that you could visit. Obviously, our own moon would be one. There are so many fascinating places like the moons of Jupiter and Saturn that you could look for signs of life in the oceans underneath their surfaces. But they're not very hospitable places. For example, Jupiter has a radiation belt surrounding it, so we would need much better radiation shielding before it would be safe for people to get out there. Venus would be interesting to visit from a distance. Obviously, the surface is not particularly hospitable. The record is about 2 hours for a probe surviving on the surface, given the huge pressures on the surface and the temperature being hot enough to melt lead. So I think in our own solar system, besides Earth, Mars is really the place to go in terms of a place that we could actually live long term with technology that we already have to date, or just with a few more innovations. That being said, if we had the ability to travel between stars, I would love to see an exoplanet with my own eyes. At the moment, it doesn't look like that's coming anytime soon. There are people working on like 1 gram probes that you could accelerate by blasting lasers at them to 20% the speed of light. But even traveling that fast, it will take you 20 years to get to the nearest star. So it's probably like a 23rd century problem, whether we can figure out how to get large things to other star systems. But if it was possible, absolutely, I would love to see an exoplanet.
All right, okay. When do you expect the first humans to land on Mars?
So I think it is possible in 2031 with how things are going at the moment. I know you often see headlines like that starships could land on Mars in 2026 or 2029 or so. But I've been tracking the Starship program very closely, and I mean they're getting things done, but it always takes a little bit longer than expected, because it's such a revolutionary new piece of technology that they're working on over in Texas there. So yeah, I think realistically it could be done in 2031. And if you look at what NASA are kind of officially planning at the moment, they're looking at around about the 2040s or so. So I think it will be accelerated by a partnership between private companies like SpaceX and with NASA, with all of their incredible expertise in human spaceflight. And we've seen that partnership work so well with things like the Commercial Crew Program, sending astronauts to the space station, with Inspiration 4 recently, showing that by NASA helping to transfer knowledge to companies like SpaceX, now more people are starting to go into space than was possible before. So I think that ideal partnership between the government and companies will speed up the process of us sending people to Mars. So fingers crossed, 2031.
Yeah. How can an atmosphere affect the probability of life on a planet?
That's a great question. So perhaps Mars is one of the best examples, because we know from the fact that there are signs of ancient lakes and rivers on Mars that once upon a time, Mars was a much more hospitable planet. And that was because Mars had a much thicker atmosphere about 4 billion years ago that was much similar in thickness to the atmosphere of the Earth. So it had a stronger greenhouse effect, trapping in heat and warming up the planet to the point where liquid water could exist on the surface. So in the case of Mars, whether it's habitable or not depends crucially on how thick the atmosphere is and what the atmosphere is made of. We see obviously on the Earth, for example, with climate change, that even a very small change in the composition of one of the minor gases like carbon dioxide can quite strongly affect the habitability of a planet. Venus is another example. Venus, perhaps many billions of years ago, could have been closer in temperature to the Earth, but we believe it went through something called a runaway greenhouse effect, where perhaps it had oceans one day, the oceans evaporated, and because water is a really strong greenhouse gas, it trapped in more heat, evaporated more water, and it spiraled out of control until Venus reached the temperatures of about 460 degrees Celsius that it is at the surface today. So both Earth, Venus, and Mars are all in the habitable zone of the sun. But the only reason that Venus and Mars are no longer habitable is because of the makeup of their atmospheres. So knowing what an atmosphere is made of is absolutely crucial for whether the planet is habitable or not. And that's why we use telescopes to try and measure what the different gases are that are there in an atmosphere.
Okay, that's a great answer, thank you. What's your plans for the future?
So in the immediate term, the James Webb Space Telescope is launching very, very soon. Assuming that everything goes fine with the launch on December 22nd, we will have 6 months or so while all astronomers like myself will be waiting with bated breath to see that everything works with the unfolding process and the period we call commissioning. 6 months after it launches, the first scientific data will start coming down. And I'm involved with many different teams and collaborations around the world that will be analyzing this data for giant planets and rocky planets and everything in between. I also have my own program on James Webb. So I'm leading a team that will be looking at a planet around a white dwarf star, which is essentially the leftover core of a star like our sun after it has died. And we found this planet last year. It's the first example we have of a giant planet passing in front of a white dwarf. So by studying that, myself and my team hope to find out what will happen to the planets around our sun after the sun dies. So I'll be working on that quite a lot over the next year or two. So we'll probably have results from our early analyses of planets with James Webb, probably around early 2023, because it will take us a little bit of time to analyze the data and then write scientific papers and then go through the process before we then announce our findings. So it's going to be a very frantic but exciting time over the next few years. And one of the recurring stories in astronomy is that whenever we get a more sensitive telescope and we open new eyes on the universe, we always find something surprising that we weren't expecting. So perhaps the thing that I'm most excited for is the discoveries we'll make that we can't even imagine right now.
All right, okay. Thank you so much for coming on here for an interview. I wish you all the luck with your research and your with what you're going to do with the James Webb Space Telescope. And I hope you have a brilliant rest of your day.
Thank you very much for having me on, and the best of luck to you and your YouTube channel.
Thank you very much. Bye.
Bye.
Thanks for watching. If you enjoyed today's video, don't forget to like, subscribe, and check out my Patreon page. There'll be a link in the description. Bye.